In this example, I'm going to show you how to use Matlab to apply it to a problem with Lagrange multipliers, kind of like in the homework problem. And so we were asked to graph some level curves for the function f, and then also to graph the constraint g. So I'm going to apply this to a problem we've already done, example 3 in the notes, because we already know where the maximum is and what the values are and stuff. Okay, so I'll start by typing 2% signs, and that's so I can execute all the commands I'm about to enter. And I'll set up a range for x values, and looking at the problem I can see that the maximum occurs at x equals -2, and so I'll make a range that is around that. So x equals linspace -3 to -1. And I also want to do the same thing for the y values, and there the y value where the maximum occurs is square root of 12. I don't know what that is off the top of my head. I'll have Matlab calculate that for me down in the command window. So square root of 12. Okay, 3.4. I'll go back up here. Y equals linspace. How about 3 to 4? So those are the x values and the y values, and now I want to make a mesh out of those, and I'll use capital letters just to distinguish between the starting values and then something a little different for the mesh. So mesh grid x comma y. Okay, now I'll enter the function. I'm going to use capital Z just because it goes with the capital X and Y. So Z equals 2 times X dot squared plus 3 times Y dot squared minus 4 times X minus 5. And now I'm ready to make my first contour graphs. So I'll just enter, I'll do it the simplest way first, and then I'll change it around a little bit. Contour x comma capital X comma capital Y comma capital Z. If I hit Control and Enter, it's produced the figure I'll show you here. Okay. And those are the contour lines for F. Okay, well now I need to do the same thing for G. So I'll say hold on, hold on, because that keeps the figure, and then contour, and I'll just enter it in one go this time. X comma Y comma X dot squared plus Y dot squared. And that's not everything I need. If I do that, it will create contour curves, but I want just one of them where it's equal to 16. And so here's the syntax. Level, list, and then 16. And I hit enter, and I'll show you the result. It's a little hard to see. This curve is the one for the constraint, and the other ones are for F. And so I'm going to change this a little bit, add some detail to make it easier to see what's going on. Okay, one thing I'm going to do, I'm going to add a single contour for F that has the right Z value, that is where the maximum occurs. So level, list, and then 47 was the maximum value. Oops, I need the Z there. Okay, and so now you can see that one of the curves for F actually touches and is tangent, parallel if you will, but tangent to the constraint at the point -2 and then 3.46 or whatever. And that's where the maximum occurs. That's good enough, but if you want to make this a little better, we can change some of the colors so that they're different for F and for G. Here's how that looks. So I would change the line color. How about we make it blue for F? At least that one will be blue. And then let's also change the line color and make it red for G. Okay, so there's this blue one, and it just touches the red one at the point -2, 3.46. And that's the end of the example.